All right, so welcome to the second lecture for week 6 of Philosophy 1500.02 Introduction to Logic Online. We're going to pick up where we left off last time, right? And we're still talking about comparing statements, but we're talking about different logical properties. This time we're comparing two different statements at the same time. Okay, so let's see what that means. Okay, so here are the big ideas. So first, multiple propositions considered together can have interesting logical properties in relation to one another. We'll see more about what that means, but the general idea is that we can compare the truth tables for two different statements or propositions, right? And they're going to bear an interesting relation to one another, right? Perhaps they're both true in exactly the same circumstances, or they're both false in exactly the same circumstances. So here are the examples, or what we're going to be talking about. So some propositions are what we're going to call logically equivalent, right? They're true in exactly the same circumstances. Next, some propositions are contradictory, right? When one is true, the other's false, and vice versa, right? So if two statements or propositions are contradictory, if one's true, the other has to be false, and if one's false, the other has to be true. Some statements are consistent, right? They can be true in at least one circumstance at the same time. And then finally, some statements are inconsistent. They cannot be both true in the same circumstances, right? So the idea would be anytime we look at the truth table for both, right, if one's true in this circumstance, the other has to be false, right? There's no row, right, where they're both true. Okay, so we're going to go through these in order. And we're going to look at some truth tables and see how to determine whether or not statements are logically equivalent or whatever, contradictory. So let's start with logically equivalent statements. So some propositions are logically equivalent, right? They're true in exactly the same circumstances. That is, they have the same truth value in every circumstance. So if you had their truth tables, right, for every row where one's true, the other's true as well. Right, so we're looking for truth tables where they have the same truth value in every circumstance. Right, that is when they're true, right? So it's not the case that both P and not Q, and if P then Q, are logically equivalent. So how will we prove this? So we're going to do it by constructing a truth table. No surprise there. Okay, so pause me, set up your truth table, go through and solve. Right, it's important that you do this on your own. Right, if you don't, then this is going to be really hard. Right, so do it on your own, give it a shot. If it doesn't work out, see when you turn this back on where it didn't work out, and then try to figure out what you did wrong. And if you can't figure it out, as always, please, please, please email me. Okay, anyway, pause me. Okay, so the first thing we do, right, as always, is we go through and we put our truth values underneath our statements. Right, so your truth table should look like this. So let's work on the left-hand side. Right, so next thing we do, right, working from the inside out, right, we're going to start with the tilde, right, rather than the dot. Right, it flips the truth value, so when Q is true, not Q is false, and when it's false, it's true, yeah, and you see. Okay, so what's the next thing we do? Well, we solve for the dot. And under there, right, we're going to combine the truth value of P and the truth value of not Q, right, to figure out what we get. So what did you come up with? So you should have come up with this. So false, true, false, false. Right, so in the first row, right, one's true and one's false, so it's false. In the second row, they're both true, so it's true. In the third row, they're both false, so it's false. And in the fourth row, one's false and one's true, so it's false. Okay, so last thing we do, we solve for that tilde, right, and that's going to flip the truth value that we just determined. All right, so what did you come up with? So you should have come up with something like this. In fact, you should have come up with exactly this. True, false, true, true. Okay, good. Okay, so we're done with one half of what we need to do. Now we need to move to the other side, right, for if P then Q. Right, and this is going to be really easy, right? This is just the truth table for the conditional. Right, so what do you come up with? Well, here's the truth table for the conditional: true, false, true, true. Okay, so we've now constructed truth tables for both of these propositions. Right, it's not the case that both P and not Q, and if P then Q. So we want to combine, or we want to compare rather, the truth value underneath the tilde, that's yellow, right, with the truth value under the horseshoe, which is green. So note in our first row, when P is true and Q is true, these are both true. Then they're both false, and they're both true, and then they're both true. Okay, so these have the same truth value in every possible circumstance, right? So they're logically equivalent. Right, same truth value in every circumstance, logically equivalent. Right, so if they're true in exactly the same circumstances, right, then they're going to share the false ones as well. Right, so same truth value in every circumstance, or equivalently, true in all the same circumstances, logically equivalent. Okay, so now we'll move on to logically contradictory statements. Right, so some propositions are logically contradictory, right? They have opposite truth values in every circumstance. Okay, so what we're going to be looking for, right, is with our one truth table for our one proposition, when that's true, the other one's false, and when one's false, the other's true. Right, so having opposite truth values in every circumstance. Okay, so this monster on the left-hand side, it's not the case that both if P then Q and if Q then P and P if and only if Q are logically contradictory. Right, so we're going to prove this by constructing a truth table again. So you should pause me right now and actually set up the truth table. Right, rather than passively receiving. Right, so pause me. All right, so when you started it, it should look like this. And then, of course, we go through and we fill in underneath the statement letters the truth values corresponding to the row. Next, we can solve here and here, right? And again, we're just applying the truth table for the conditional. Right, then we solve for what? The dot. So when the left-hand side, the left conjunct is true, and the right side, if Q then P is true, right, then it's true. When they differ in truth values, they're false, right? And then at the bottom, they're both true, so it's true. Okay, so we have one more thing to do on this side, right? That's the tilde. So we have false, true, true, false, right? And that's just taking the information we just did that's in green and flipping it. So from true to false and false to true. Okay, so next thing to do is P if and only if Q, right? And again, this is just a truth table for the triple bar or the biconditional. Right, so true, false, false, true. Okay, so what we want to do now is compare that information, right, under the triple bar with the information under the tilde out front of the bracket, right, the last thing we solved on the left-hand side. Okay, so note in the first row, when the left thing is false, the right thing is true. In the second row, when the left thing is true, the right thing is false. Same with the third row. And then in the fourth row, right, when the left-hand side thing is false, the other thing's true. Right, so in every row, they have opposite truth values. Right, so these are logically contradictory. Right, so opposite truth values in each circumstance, logically contradictory. Okay, so here's something worth noting, it's both the case that if P then Q, and if Q then P, and P if and only if Q are logically equivalent. So we can prove this by constructing a truth table. So note that the thing on the left-hand side of the truth table, it's both the case that if P then Q and if Q then P, right, is just what we had minus that not out front, right? So we've solved for the entire thing, right, and we just go back a step. Think about it that way. Then we have true, false, false, true. That's in green. Well, compare that to what we have on the right-hand side, true, false, false, true. Well, what do you know? They have the same truth values in each circumstance, right? So we've encountered this before, right? They're logically equivalent. All right, so next we have logically consistent statements. So some propositions are logically consistent, right? They're both true in at least one possible circumstance, right? When we say they're logically consistent, then what we mean roughly is something like, given the laws of logic, they could both be true. Okay, so what we're looking for is a truth table where there's a row where both propositions are true. All right, so let's prove that P and not Q, and if P then not Q, are logically consistent. So of course we'll do this by constructing a truth table. So build the truth table and solve. Pause me. Right, so this is what it should look like when you set it up. So what will we do? Well, we'll go through and we'll put our truth values underneath the sentence letters. And remember, what we're looking for here is a row, right, where both propositions are true. If there's at least one, then the propositions are logically consistent. So solve this. So here's what it should look like in the end. So here's a row where they're both true, right? So there is a row where both propositions are true, right? And if there is at least one such row, then the propositions are logically consistent. So here's an aside. Any two tautologies are logically equivalent. So why is that? Well, think about it this way. Statements are logically equivalent if and only if they have the same truth value in every circumstance, right? Tautologies are true in every circumstance, right? So any two of them have to be logically equivalent, right? Because in any circumstance, they're both true, right? So any two tautologies are logically equivalent. So if two propositions are logically equivalent, does it follow that they're logically consistent? No. Well, why? Well, think about it this way. Two propositions are logically equivalent if they have the same truth value in every possible circumstance. Now consider self-contradictories, or contradictories. Well, actually, consider two self-contradictory statements, right? Ones that are false in every circumstance, right? Then it would be the case that they're not logically consistent, right? Because there's no circumstance in which they're both true. In fact, there's no circumstance in which they're true at all, right? Individually, right? So here are propositions that are logically equivalent, right? Any two self-contradictories, but they're not logically consistent. Okay, finally, logically inconsistent statements. Some statements can never be true at the same time. So what we're going to be looking for when we build truth tables for them is a truth table with what feature do you think? No row where both statements are true at the same time. So P and Q, and it's not the case that either P or Q are logically inconsistent. Okay, so let's prove this using a truth table. Okay, so set up the truth table, solve it. And then, unpause me. So here's what you should come up with. So note that they never have the same truth value. So true and false, false and false, false and true, and false and true. Right? So these are logically inconsistent. Okay, so here's our summary, right? So multiple propositions considered together can have interesting logical properties in relation to one another. So first we said some propositions are logically equivalent, right? They're true in exactly the same circumstances. Some propositions are contradictory, right? When one's true, the other's false, and vice versa. Some statements are consistent, right? They can be true in at least one circumstance. And then finally, some are inconsistent. They can't both be true at the same time or in the same circumstances.